Welcome to this Gestalt IT Roundtable discussion brought to you by Intel. In this video, we're going to be discussing digital infrastructure at scale with a group of IT luminaries. Specifically, we're focusing about server architecture choices and the ecosystem involved. Before we begin, let's quickly meet who's on the panel today.
Hello, my name is Craig Rogers. You can find me on Twitter at CraigRogersMS or at www.craigrogers.co.uk, and I'm also available on LinkedIn.
Hello, my name is Athar Beg, and I'm also a blogger and podcaster. You can find me on the Twitter with the handle Athar Beg. My blog is atharbeg.com, and you can also find me on LinkedIn.
I'm Alistair Cook, and you can find me on Twitter as at DemitasNZ or DemitasNZ if you'd prefer, as well as at demitas.co.nz for my blog.
Hi, this is David Scheer, and I'm with Intel, and you can find me on LinkedIn as well.
So, all of us have been working for a few months now on a white paper for Gestalt IT focusing on server architecture selection. This has been a really exciting and interesting project for me, and I think that for all of you as well, since it really gets to the heart of everything we do here with IT. That is, how do you pick the right hardware to match software? How can you build an entire scalable infrastructure? And what choices matter and what choices are you going to make in 2022? So, David, I'm going to throw it to you to sort of kick things off. What were you looking for, and what do customers look for?
Well, that's a great question. The IT infrastructure complexity is something that sometimes we kind of gloss over. When we think about Intel, sometimes you might think about, it's just a single processor, a single product. But what was a lot of fun in this project and talking to you guys today is it's really about the entire ecosystem. So there's a historical aspect to it, and there's a large ecosystem around the world that is, not just the hardware itself, but the software. And then what is happening in that ecosystem in terms of things like cloud, hybrid cloud. And so going through all those different things, items to consider, what is beyond just the CPU itself and what's happening, I think is really interesting. And I think this paper and what we're talking about can actually help IT folks really kind of parse and understand the types of questions they should be asking and figuring out and what Intel does in this space, because we happen to work with a lot of people all over the world.
No, I completely agree because that's when I was looking at the market as well. I think we all see this trend emerging that there's a narrative being pushed by some companies, maybe marketing, that the best processors are the ones that have the most cores or more clock speed, and your system must contain those processors if you want to get the maximum performance out of your hosts in your data center. So when writing the white paper, I'm basically arguing that this view is short-sighted, and there's a lot more to building a system. And most organizations, and especially if we're talking about service providers, where they bulk buy large quantities for their data centers, and they have heterogeneous workloads working on their environments. They don't particularly care about having the faster processor. They understand that there are many components that make up the perfect configuration, and what suits their needs. And what they have to look for is the best cost performance ratio for their environments, for their deployments, so that their data centers can keep operating and giving them that performance and yet be cost effective to their businesses. And that's the best way of going through a configuration that's perfect for their data center.
I think it is really important to recognize that application performance and value isn't just driven by the number and amount of CPU cores, that there's actually got to be a system view and a balance. And that's something that really came through, and particularly Athar's writing about the right collection of parts to have together. That it's not just a bunch of CPU cores, that there's also that balance to other resources and particularly to capabilities on the CPUs, because that's something that Intel has been working on for a long time, is adding additional instruction sets to accelerate specific fairly common use cases. We used to use hardware offloads for all of our SSL encryption. Well, we now do that in the actual CPU cores, and that's an important characteristic of just not the number of cores, but the capabilities as well.
The entire ecosystem of products have really started to gel well in recent years, and the notion of accelerators accelerating their own individual functions, and as you were saying there, Al, about instruction sets accelerating things like SSL, there were other ancillary benefits to that. If you were doing backups and they were encrypted backups, they also benefited from that, 4 or 5x was seen historically just in going from a V3 CPU to V4. It was a big jump, and it's good to know that these parts are all tested as part of a wider ecosystem. Intel CPUs work well with Intel chipsets, with Intel network cards, with all the other accelerators available as part of that XPU framework, where different aspects of hardware are accelerating different functions. And with the move to CXL, we now have this universal bus that's going to let us accelerate things further on the same tie. It's really exciting the way things are going.
One of the narratives that I've struggled with for a while is that the cloud means I don't care. And this is something that I've found is really, it's a very shallow view of what using public cloud resources, particularly in combination with on-premises resources. That the reality is public cloud is not just an undifferentiated sea of CPUs. There are special function capabilities in different servers for different functions that run on there. And that visibility of the capabilities that you might use on premises inside your cloud-hosted instances and the applications that run there is going to be crucial to a modern hybrid and multi-cloud environment for customers, getting those same benefits in the public cloud as you get on premises. Because one of the wonderful things about the public cloud is you only pay for the resources you use. But the terrible thing about the public cloud is you pay for every resource you use. And so you want to get the most value out of the resources you're paying for in the public cloud, the same as on premises.
That drive of efficiency, though, it can be a good thing. It forces you to look and see what actual resources do I need to run that workload in that cloud. It may be a public cloud or private cloud. That level of insight required to do that efficiently, it has been a great thing over the last decade. It's forced people to look more closely at their workloads and gauge accurate requirements.
Yeah, the myth of the sunk cost of our on-premises virtualization infrastructure goes away when you shift out to public cloud.
Exactly. I mean, that I've always been a big believer of having the right workload in the right cloud. And it seems to be that in recent years, it has become quite clear that while the trend was once going to the public cloud only, and let's get rid of the private cloud side of things, now the trend is going, go back to the private cloud and have a hybrid environment instead, so that you're not reliant on one particular side of things. And it's clear to me that it doesn't really matter which cloud you sit in. The ecosystem of that Intel has actually developed basically means that it's present in both environments. So there are capabilities that you can use in both environments, because you will have to live in both environments eventually. Whatever you need drives you to do. And going back to the point that Craig was making about the efficiency of a deployment, that's the flexibility that public cloud gives you, that you don't keep expanding your private cloud if you don't need to. If it's a temporary requirement, you go to a public cloud, the case that you normally use for public cloud, and then burst when required is what I'm getting at. And then hence you are efficiently using your resources, not necessarily burning those resources that we so dearly don't want to spend.
I would imagine that Intel have seen a shift in how customers are consuming their products. Historically, you might have had 10,000 customers in a quarter go for a 3 or 4 node cluster, so it'd be 6 or 8,000 processors going out. Now you're probably seeing more hyperscalers buying in larger chunks and less from the small businesses, as people have moved their workloads predominantly up to cloud infrastructure.
Well, I think one of the big changes for cloud or hybrid cloud is the level of granularity that's happening in that particular environment. So, just recently we just made an announcement with AWS about continuing developing solutions on their infrastructure and internal workloads, right? Our IPU that we just came out is kind of an example of that. So having an understanding of workloads at a very granular level is super crucial to really help define and deliver solutions across all different types of industries. And the connection between those. I mean, that's the other part of it. Um, One of the key things I think for having a large ecosystem that's running on in working with a company like Intel is that it allows you can take your workload or application, it's running in the cloud. It's likely to have the same functions or the same application actually on-prem or even between clouds. And that's one thing that I think IT folks have to start looking at. I think they have, but continue to ask more questions about that and make sure. So, as they want to make sure that their solutions and where their data resides is all going to be supported and securely supported across all these different options. It's a super interesting time for that level of what might have been a common approach, a general purpose CPU into a very granular kind of look at how these things work. And it's very different than I think in the last few years.
That's an interesting aspect, and something that I think came up in the white paper was this sort of dichotomy between considering a CPU to be sort of a general purpose uh, building block versus a CPU to be a very specific infrastructure component. And one of the things that came out of this as well was that idea that uh, CPUs increasingly are including accelerators as well. The CPUs, especially from Intel, are including accelerators for specific functions. And this means that even though we're abstracting things and we're using the CPU as a sort of a generic compute provider, it still matters the exact features and functions of that particular processor or processor family, right?
I think we came to a very significant, it depends on your use case element in this. That there are some very specific use cases where the perfect configuration is really important. And so there are very specific instruction sets that you need for maybe running a massively scaled uh, compute environment for running essentially high performance compute. Uh, but if you're running more of a general purpose platform that's going to have a mix of workloads on it, and that's what those of us from a virtualization background are most used to, then you need to have the collection of the different elements that are required by the different workloads that are running. So you might have different sets of instruction sets that are absolutely crucial for high performance compute that are less vital to you as you're doing a less highly tuned, more general workload. But you still are going to look for some common benefits. That Craig's example of a backup system that was accelerated by 3 times by using newer instruction sets. Well, if you lose those as you migrate to the cloud, you can have a significant poor performance moving onto the cloud. And we've seen customers do this previously with things like misconfiguring the memory allocation on their machines in the cloud and having very poor performance and blaming the cloud for what was in fact a poor choice as they did the migration process.
I think you're right, Al. This configuration that we talk about, it can work in funny ways, because one of the things that I was looking at when writing the piece of the configuration was that there are certain things that actually Intel has introduced that are quite unique and innovative in terms of configuration, which you can also get wrong, by the way. But if you get right, then you can actually go beyond the physical limitations of that host that it can support in terms of RAM, for example, using the Optane technologies. And that's an interesting aspect of me as for me as well, that you're looking at extending the life in a way, or the architecture that you're working with, and configuring it correctly and sizing it properly so that you can host or cram as much as resource as you can on that host, and effectively saving a lot in the process. And that's an innovation that really was quite interesting to me when it came out. Um, so I think it's one of those kind of things that you do miss in other architectures that every now and then come across that really makes you think that how you can think differently when defining your DC architecture.
I think the recent announcements on Optane to some may have been shocking, but if you look at it, it's a logical progression. It's newer, faster storage was required. Optane provided that function. Now we have CXL. It's just a different bus. It's faster. It's going to give us more options, more throughput. It's a better way of doing it, and it's a lot more standardized. Would be very it will be relatively easy for hardware manufacturers to introduce support. It's using standardized configurations in terms of delivering that hardware. So we're going to see large RAM modules that just plug in. CXL has got a direct bus to CPU. It's going to be brilliant. It's going to be good. It's going to open up a lot more possibilities. Optane really, a lot of changes came in storage whenever Optane memory came. It a lot of companies leveraged that capability very well, and now they're going to be able to do so further, even with CSKL. I'm genuinely excited to see what comes.
It does seem that the industry has caught up with what Optane provided, that it's not that we're losing a capability as Optane's being retired, more that capability is available in other ways. So certainly when Optane was new, it was absolutely mind-blowing. We couldn't conceive that things would work this well. And now, some years later, we've found that the rest of the industry, the rest of the capabilities of storage have caught up a little, and that gap that you might have felt was going to occur because Optane goes away isn't actually a gap, because there are other products that are going to fill that and other capabilities that will fill that requirement.
Yeah, it's just a different bus. If you remember back to the PCI days, AGP came and accelerated graphics port did one thing very well, and then PCI Express came and it's like, oh, we can do other things as well, and we have more bandwidth than what we had before.
Yeah, exactly. I mean, you learn as technology develops, right? In usage as well as while building a system or developing the innovation that companies develop. You stand on the shoulder of giants, I guess, and you learn in the process. So even if this technology goes, it gets replaced by an even better technology. So I'm not too bothered about it. The lessons that are learned as part of that technology progression, that can only help. So I'm actually happy. I'm all for that change. But going back to the ecosystem side of things, one of the other things I was when I was researching and I started thinking, I realized that one of the things that's easily missed when trying to gain performance out of a system is that if you are with a manufacturer that has this diverse ecosystem, everything from chipsets, networking, everything like that, and you're defining your system based on that, while there are other ways of doing it, it's sticking to an ecosystem actually has so many more benefits, because some of the code that's coming from the same manufacturer that's being put into in advance into the drivers, for example, or BIOSes, or all those different things that make your system gel together. Those efficiency that are created like that, is an often forgotten fact that those efficiencies make your system go faster and you hit less problems. There are no less support issues and all those kind of things, which is a very critical one of the most critical factors, I think, that service providers look at when they're looking at the systems of their data centers futures. So I think the ecosystem of products is one of the key things that should not be forgotten.
Agree. Also works very well commercially. If you're working, buying most of your stuff from a single vendor, you're going to have a better relationship spanning multiple products. And it can bring other ancillary benefits there as well. Plus, if you have two separate vendors competing, it rules out the opportunity for one to blame the other.
I think that one of the other things I was thinking that, since when I started in computing, very old days, I say, um, not giving out my age or anything, but with the x86 processors when the series came out, and since then in older days, the computers developed data centers, got the servers containing that virtualization or bare metal, and then all the chipsets, the entire ecosystem. And now we're in the hybrid cloud environment, and we are talking CXL and all those kind of things. The one thing that stands out for me is that the only constant in all of this has been Intel, because other companies have come and gone. But whenever we talk about such technologies, whichever cloud we are talking about, is Intel there. So so that's something that stands out, that there is this pedigree that you can sort of rely on when you're talking, when you're designing systems and thinking about the longevity going forward in terms of innovation and compatibility of systems.
Yeah, let me just on the ecosystem question, on that question as well. I think that one of the things that really struck me when we were doing our work here together was this idea that it really matters, the breadth of offerings and the breadth of choices that you have really matters, because there are different implementations that need something much more small and integrated. There are things that need something huge. You need it in the cloud. You need it on premises. You need it from multiple ISVs. You need it from multiple clouds. If you're an enterprise trying to build a scalable and sustainable platform, it really matters how many choices you have, and how widespread it is in the industry, not just the specifics of one product versus another. Is that sort of where we're going there?
Well, I would also point out yeah, it's the variety, it's the scale, um, and also, software is so important. We're such a hardware company. We'd love to talk about hardware, but it's software all over the place. In that fundamental open source software, the amount of folks that we have, that Intel has, that actually is out working with these different companies. So making sure all of that software is not just tested and validated, but has all the latest features. So that's another aspect of, a modern data center, making sure you have the latest versions of all those, different OS and applications that are out there. Um, and a lot of the new applications are built upon these fundamental aspects of whatever Linux or what have you. So we want to make sure all of that is all working together, and it drives a lot of really interesting innovation. Talking about the Optane thing, Vast was one of those companies that actually really started based on this new technology, and Intel does that all over the place. And sometimes they don't talk about it as much, but I think that is a key part of the Intel value, in terms of not just the hardware, but a lot of the software, and the different things, that innovations, standards, and specific solutions, that we have a lot of those engineers in those different companies delivering on that software. And that's a lot of times it's invisible, or the IT community magically gets the benefit, and they might not even realize that. So um, you know, it's a good thing, but we want to make sure that they understand that too.
I think that plays at one of the really important things about running production, is that running production should have all of this kind of boring element to it, that all of these things should be just hidden and working underneath. And the reality is that there's a huge amount of work to make production boring, and that Intel is contributing to making production boring for a very large number of customers.
I agree, and that's where the benefit of the ecosystem comes in, and that it's, if everything is being covered by those software developers, and be it the firmware, be it the drivers in the operating systems, be it increasing efficiency in all that code, and it just works. Um, we all remember, I think, the days of when you had to bind each particular driver, like all the drivers, to the network card by hand. Um, so nobody liked all of that, and suddenly everything became plug and play, and not quite. But over the years, all of this has become very seamless, regardless of whichever operating system you pick, regardless of whatever, even containers and all those kind of things will run smoothly over any operating system that has been made possible because of the underlying subsystems working seamlessly. So I think the benefit of that ecosystem actually goes far deep, and people don't normally realize that when you're working with multiple vendors, um, that's something that you might have compatibility, but not efficiency.
I think that's something we might see more of now with Pat Gelsinger coming back. It's interesting now that with Sapphire Rapids coming, we're going to have the CPUs, GPUs. One API has been built on top of that. We'll have other things there like XPU Manager. You might even see object storage creeping into the mix shortly, following some recent announcements there. So it'll be interesting to see how the software ecosystem grows along with that gelled hardware ecosystem underneath.
And of course, that software will act as sort of a glue for the entire platform. I think that that's one of those things that really helps to spread the use of platform-specific features wider, and then that enhances the value of those features for everyone because it makes them more useful, more important to the overall application stack, and enhances the choice to be made.
Particularly with service providers, the likes of one API, they're going to have, there's going to be DSIM applications, they'll be able to drill in and see CPU temperature, GPU temperature, they can place that physically in a data center map, identify hotspots. It gives a much greater abstracted view using a very aptly named one API.
So, to wrap up, let's talk a little bit here about each of your takeaways from the paper. So, again, I'm going to just go through the three authors first, and then we'll let David finish up with the takeaway overall. I guess let's go in reverse order this time. Al, what was your biggest takeaway from this project and from this paper?
I think it's fundamentally that even in hybrid cloud, hardware still matters, and that using the hardware to its fullest value doesn't just mean treating it as a commodity.
Right. For me, I think it's about all about the ecosystem and creating marginal gains in your configuration to achieve the maximum performance configuration. That's the kind of thing, and which the ecosystem actually plays a big part in addition to the hardware side of things. So that's my takeaway, that building on this infrastructure actually allows you to do that, which is very something that I've not seen anywhere else.
And for me, it was the shining of the spotlight on just how ingrained Intel actually are in all of these workloads, and providing the ability to do more workloads than you ever thought. You've got Habana, we've got, CPUs, GPUs, infrastructure accelerators. There's just so much there, and it's only when you read it as a whole and piece it together that you realize the scale and scope.
So I guess what you're also saying is that in addition to the Intel Inside sticker, Intel should also bundle Intel Everywhere sticker.
Perhaps. Perhaps.
What I thought was great about this was you're taking a very complex environment with lots of different moving parts, and I thought you guys did an excellent job of putting a construct together to help IT folks really navigate and ask the kinds of questions that are going to help them get to the answers that they need for their particular solutions. So that's why I really encourage people to read this, because it's taking all of these things that are all over the place, putting a nice framework together, and then making sense of all these different pieces because they are connected and they do provide value. So I think it would be very helpful for the IT community.
And as for me, I think that the thing that strikes me is that we tend to nerd out about numbers and metrics and how many cores, how many gigahertz, how many gigabytes, terabytes, petabytes, flops, ops, all those things. But yet, when a company is trying to build an IT platform, a lot of that stuff is much less important than the sort of bigger question of is this thing going to be scalable? Is it going to be sustainable? Is it going to be supportable? Is it going to run in the long term? That's not to say that those things don't matter. They absolutely do matter. But if you can achieve similar results from a system that's scalable and supportable, then it makes those things seem to matter a lot less. And as all of you said, I think that the interesting thing here is just how many aspects go into the decision point when deciding how to build a infrastructure at scale. It's not all about the CPU. It's about everything. So before we go, if people would like to continue this conversation, I encourage you to go to gestaltit.com and download the white paper, Digital Infrastructure at Data Center Scale, which will be available on the homepage of gestaltit.com. I also encourage you to look at techfieldday.com and check out the Tech Field Day showcase presentations by the three authors of this white paper. So you can find those at techfieldday.com as well as on YouTube. And for each of you, if you'd like to continue the conversation with any of the folks here on this roundtable discussion, let me give a chance to jump in with a reminder of your social media or wherever else people can continue the conversation.
I'm Craig Rogers. You can find me on Twitter at CraigRogersMS or at craigrogers.co.uk for my blog, and I'm also available on LinkedIn.
I'm Atharbeig. My Twitter handle is also Atharbeig, and not surprisingly, my blog is also atharbeig.com. You can also find me on LinkedIn as well.
I'm Alistair Cook, and you can catch up with me online, but if you'd like to meet me in person, I'll be at VMware Explore running the V. Brown Bag Tech Talks, both in San Francisco in August, but also in Barcelona in Spain later on in the year. So if you'd like to catch up and talk in person, it's always a fun time to catch up at these conferences.
And I'm David Scheer, and I'm on LinkedIn.
And as for me, Stephen Foskett, you'll find me at Gestalt IT in Tech Field Day. You can find me at sfoskett on most social media sites as well as on LinkedIn. So thank you for joining us for today's roundtable discussion. If you enjoyed this discussion, please do subscribe to the Gestalt IT newsletter at gestaltit.com and check out the companion pieces I mentioned, the Tech Field Day showcase videos at techfieldday.com or on YouTube, and of course the full-length white paper, which is available at gestaltit.com. This roundtable discussion is brought to you by Intel, as well as gestaltit.com, your home for IT coverage from across the enterprise. Thanks for listening.